This lesson is the 7th in our series. My name is Kayla Anderson, and I'm an 8th grade math teacher at Rocky Fork Middle School in the Rutherford County School System. I'm so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see our previous lesson, you can find it on the Tennessee Department of Education's website at www.tn.gov/education. If you don't already have the student packet for this lesson, you can find it online at www.tn.gov/education. You can still tune in to today's lesson if you haven't seen any of our others, but it might be more fun if you first go back and watch our other lessons since we'll be talking about things we learned previously. Today we will be learning about subtracting positive and negative fractions and decimals in mathematics. Before we get started, to participate fully in our lesson today, you will need paper, pencil, and a surface to write on. Okay, let's begin. I want you to think about these two expressions. -3 plus -7 and -3 minus 7. I want you to think about these two expressions. Remember that expressions do not have equal signs. And what I want you to think about is, how are these two expressions different and how are they the same? Well, they both have the -3, but one is adding -7 and the other is subtracting +7. I'd like you to simplify each one of these. -3 plus -7 equals -10. -3 minus 7 also equals -10. What strategy did you use to simplify? Did you use a number line? Let's remember how to add integers on a number line. Okay, so to model -3 plus -7, which is the first expression that we started with, we are adding the opposite of 7. So we're starting at -3. And we are adding the opposite of 7. So what direction does that mean we move on the number line? That's right, we're going to move to the left. So I'm going to move over 7 places to the left. 1, 2, 3, 4, 5, 6, 7. And I'm going to end at -10. That means our answer is -10. Now let's model -3 minus 7, which is the second expression that we had, which also equaled -10. So again, I'm going to begin at -3. When we are subtracting 7, which direction do we move? That's right, we move to the left 7 places. So again, I'm going to move to the left 1, 2, 3, 4, 5, 6, 7 places. We ended at -10. That means our answer is -10. Since they both equal -10, we can say that -3 plus -7 is equal to -3 minus 7. In other words, adding -7 is the same as subtracting +7. Remember that -7 and +7 are opposites. This means that they are the same distance away from 0 on the number line. One important thing for you to notice is that when we add opposites, we get 0. So -7 plus its opposite, which is 7, equals 0. When we add opposites, we get 0. Okay, so now what we'd like to do is use a number line to work with positive and negative decimal values. So let's take a look at this first scenario. Okay. So During December, the average daily temperature in a town was -1 7/10 degrees Celsius. The average daily temperature in the same town is 2 3/10 degrees Celsius in January. What is the difference in the daily temperature from December to January? What strategy will you use to solve this problem? That's right, we should write an expression. We should also use a number line. Let's work on both of those. First, let's write an expression to represent this situation. I'll pause so that you can write your own expression to represent this situation. What did you write? You could write 2 3/10 minus -1 7/10. Remember from yesterday that subtraction can represent distance. Is there another way that we can represent distance? That's right, we could also use absolute value. How would we represent distance in this problem using absolute value? Remember from yesterday that absolute value is the distance that a number is from 0 on the number line. Good. We could write the absolute value of 2 3/10 plus the absolute value of -1 7/10. The absolute value of 2 3/10 is the distance that 2 3/10 is from 0 on the number line, which is 2 3/10. The absolute value of -1 7/10 is the distance from 0, which is 1 7/10. Adding those together gives the total distance. That's kind of tough to see. Let's put it on a number line. Okay, so here's a number line where I have -1 7/10 and 2 3/10. Does this help? Good. How can we use this number line to find our answer? One strategy would be to count the distance between -1 7/10 and 2 3/10. We could count that distance there. That does work, but it's not very efficient. We should probably just stick to our expression and work with absolute value. So remember we talked about the absolute value of 2 3/10 is the distance from 0, which is 2 3/10. You can see that here on our number line. From 0 to 2 3/10 is a distance of 2 3/10. Plus the absolute value of -1 7/10. -1 7/10 is 1 7/10 away from 0. When we add those two absolute values together, we get 4. Great job. What about if we looked at the expression as 2 3/10 minus -1 7/10? So remember, we wrote that to begin with, and then we started talking about how to use absolute value to help us with that. What if we went back to our original expression of 2 3/10 minus -1 7/10? Remember that we learned in lesson 6 that this is the same as 2 3/10 plus 1 7/10. In other words, when we are subtracting, we can add the opposite of the last addend. When we are subtracting, we can add the opposite of the last addend. We often call this adding the opposite. So 2 3/10 minus -1 7/10 is the same as 2 3/10 plus +1 7/10, because the opposite of -1 7/10 is +1 7/10. So 2 3/10 plus 1 7/10 equals 4. Notice that when we used absolute value and added our absolute value, when we added the opposite, or if we had counted the distance on the number line, which would still work but isn't quite as efficient, we're getting 4. Let's answer the question. The average daily temperature in January is 4 degrees Celsius, or the difference in the daily temperature, 4 degrees Celsius. Okay, Let's use what we have learned so far to answer this question. Oops, sorry. Okay, there we go. So on Monday, the low tide at Cook Inlet, Alaska is -1.5 feet. On Tuesday, the low tide is -1 1/3 feet. How does the low tide on Tuesday compare to the low tide on Monday? This one's a little different. What strategy might help us set up the expression? That's right. Let's use a number line to help figure out the expression. So here I have a number line, and I have labeled -1 1/2 and -1 1/3. Both numbers are on the same side of 0. What operation can find the distance? Subtraction. Let's try writing an expression now. Go ahead and try writing an expression to represent this. What does your expression look like? We could write -1 1/3 minus -1 1/2 to find the difference in the two amounts. Remember that because we're finding difference means subtraction. We know that we can add the opposite. We just discussed that in our previous example. When we're subtracting, we can add the opposite. And so this will be -1 1/3. We're going to add the opposite. What is the opposite of -1 1/2? Right, +1 1/2. So instead of subtracting, we're going to add the opposite. In order to add the opposite, we have to find a common denominator. Go ahead and do that now. I hope that you found your common denominator to be 6. So when converting these to have a common denominator, -1 1/3 will be -1 2/6 plus 1 1/2 with my common denominator of 6 is 1 3/6. Now we can decompose this 1 3/6 to make this problem a little bit easier to think about. So, if I leave -1 2/6 and then I decompose this 1 3/6, 1 3/6 is the same as 1 2/6 plus another 1/6. So ignoring this here for just a second, if I have 1 2/6 and I add another 1/6 to it, that is 1 3/6. Now decomposing this just makes things a little bit easier for me to work with here as I'm adding these numbers. Since -1 2/6 and +1 2/6 are opposites, they add to 0. I'm going to come over here. So -1 2/6 plus 1 2/6, they are the opposites of one another. They add to equal 0 plus that other 1/6 that I have, which equals 1/6. This means that the low tide on Tuesday is 1/6 feet higher. Let's continue this with a couple more problems. I want you to help me with this one. Make sure that you follow the process of creating a number line to represent the situation. Then write an expression before you answer the situation. So we're going to read another problem. You're going to draw yourself a number line, and then you're going to write yourself an expression. So here's our next problem. A path from a dry lake bed starts at an elevation of -12.5 feet relative to sea level. The path ends at an elevation of 60 1/3 feet above sea level. What number represents the change in elevation from the start to the end of the path? Write an expression that represents this situation. Okay, let's think about what we've been working on. We want to first think of a strategy that might help us set up the expression. Remember that a number line, drawing a number line and looking at it and thinking about the numbers and how they're related to one another can help us to write ourselves an expression. Go ahead and draw the number line that represents this situation, and I will wait. Okay, I have drawn a vertical number line. And I have 0, which is going to be sea level. And then we were told from the problem that the path starts at an elevation of negative 12.5 feet. So this is where the path starts. And then it ends at an elevation of 60 1/3 feet above sea level. So here is where the path ends. Okay, so we can see here, started at negative 12.5 in comparison to sea level, and then ended at 60 1/3 feet in comparison to sea level. And we want an expression to represent this change. Okay, so now that you have your number line, use the process that we walked through just a second ago to write yourself an expression for this situation, and I'll wait while you do that. Okay, did you get 60 1/3 minus negative 12 1/2 to find the difference in these two elevations? Great. So now I'm going to let you finish this one up, and then we will check our answers to see what the change of elevation is. I'm going to pause now so that you can finish solving this. Okay, let's check your answer. So we have learned earlier that when we're subtracting, we can add the opposite of the last addend. Remember that we often call this adding the opposite. So 60 1/3, we can add the opposite. So what is the opposite of negative 12.5? Right, positive 12.5. So now we're adding 60 1/3 plus 12.5. You do have to find a common denominator here. If you've already switched to adding the opposite and you've already found your common denominator, finish your problem out. If you didn't have a chance to find a common denominator, please do that now. Okay, so did you get a common denominator of 6? Let's make sure that we rewrote our mixed numbers properly. So my whole number of 60 does not change. I need a common denominator of 6 here. My whole number of 12 does not change. Common denominator of 6. So 3 times 2 gives me 6. So to make this an equivalent fraction, 1 times 2 is 2. So 60 2/6 is the same as 60 1/3. Here, 2 times 3 gives me 6. To make this an equivalent fraction, 1 times 3 gives me 3. So 12 and 3/6 is the same as 12 and 1/2. Now that I have those common denominators, I'm going to go ahead and add. Remember that you'll add your whole numbers first. 60 plus 12 is 72. And then we'll add our fractional pieces. 2/6 plus 3/6 is 5/6. And let's make sure we label that with our units. So the change of elevation here is 72 and 5/6 feet. Now, keep in mind when we look at our number line, let's think about the reasonableness of this answer. If we started at negative 12 and 1/2 feet, we would have had to increase by 12 and 1/2 feet just to get back to sea level. Then we would have had to increase our elevation by another 60 and 1/3 feet. So it does make sense that from a negative 12 and 1/2 to increase up to 60 and 1/3, that I'm going to have a positive 72 and 5/6 feet as my change in elevation. Now, here is one more for you to try on your own. I'll get this ready for you. In the previous problem, we also know that the lowest point of the dry lake bed has an elevation of negative 18 and 3/4 feet. What is the change in elevation from the start of the path to the lowest point in the dry lake bed? Show your work. I am going to pause and give you enough time to read over the problem again, draw yourself a number line, write an expression, and then solve that expression. I do want to remind you as I pause to let you work on this that it does reference the start of the path, and that was from the previous problem that I had on the screen, and the start of the path is at negative 12 and 1/2 feet. So now you have the numbers that you need. I'm going to pause so that you can draw yourself a number line, write an expression, and solve this problem. While you're continuing to work, I will go ahead and show you the number line that I came up with for this one. So the start of the path was at negative 12 and 1/2 feet. And the lowest point was an elevation of negative 18 and 3/4 feet. Okay, so I drew a vertical number line here to represent that. I'll let you continue to work. Okay, so we are finding the change in elevation from the start of the path here to the lowest point. Now that we've looked at the number line, let's write an expression. I hope that for your expression you came up with negative 18 and 3/4 minus negative 12 and 1/2. Now, what we've talked about over the past couple of examples is that when you're subtracting, you can add the opposite. Remember, we've written that several times, adding the opposite. So, negative 18 and 3/4 plus the opposite of negative 12 and 1/2, which is positive 12 and 1/2. We are going to need a common denominator of 4 here. So negative 18 and 3/4 plus 12 and 2/4. Negative 18 plus 12 is negative 6 and 3/4. Negative 18 and 3/4 plus 12 and 2/4. When we add those two together is negative 6 and 1/4. Goodness. So the change in elevation is negative 6 and 1/4 feet. Great work today, folks. Today we practiced subtracting fractions and decimals. I hope you're seeing some connections to subtracting integers and subtracting fractions and decimals. You really did a great job today. After the video, you're going to have some problems to practice on your own. I will show you the independent practice problems now, or you can find them in the student practice for this lesson posted on our website, www.tn.gov/education. Here is that independent practice. You are given 3 problems here, and you have been asked to solve the given problems and then to make sure to include a number line in your solution path. Good luck on this, and make sure to do your best. I enjoyed reviewing subtracting fractions and decimals with you. Thank you for inviting me into your home today. I look forward to seeing you for Tennessee's next at-home lesson. Bye.